Hey, good morning, fourth graders. Welcome to our robotics class. This is week 22. So this is our week before the break. So just a reminder, if you're missing any of the robotics assignments from third quarter, please catch up with them over the break. So we've been spending the quarter, we've started out learning about the engineering design process. We learned about engineers, and we've been going through in more detail each of the steps in the engineering design process. And there we've been, for your assignment, you've been getting these short little review sheets where you have to fill in the blanks and answer the questions. And it's pretty much all the answers are from our video lesson. So we're going to continue with that this week. And last week we learned about variables. So this week it'll kind of review a little bit about that. And then we'll be learning about testing. So the step in the engineering design process where engineers have to actually test out the solution and be like, okay, does it actually work, right? And if it does, is it a winner? Meaning that, like, can we move forward with it? So we'll be watching our video series on that. So I'll be putting that on in a few seconds. And then you will be getting another review sheet that you can fill in for your homework this week. So please, you can always check GradeLink and go in. And if anything has a 0 or a not graded, it probably means that you didn't do it. If you did email it to me, but I just didn't update it yet, just give me a few days and I will update it. If it's been a long time and you still don't see it updated, you could reach out to me just so we could make sure that your email I did receive it. But otherwise, yeah, just use the break to catch up on anything that you might be missing. Okay. All right. So I'm going to put on the videos now. So again, if you want to take out your notebook, your binder, be jotting down some notes, that would be good. If you even want to have the review sheet with you, have it opened, and you can fill it out as you're following along with the lesson, that might be a good idea. It really just depends on what you can do and what's available to you. But you always have the video to go back to, and you can pause it if you need to go and check on anything. Okay, guys? All right, so hang on one second.
You should know by now what's great about engineers. They solve problems. All kinds of problems. I know when we think of engineers, we think of big problems like crossing gorges, but consider things we use every day to solve little problems. You probably remember that one of the steps of the engineering process is testing proposed solutions, and engineers always approach testing with a plan. So let's check it out and see what steps engineers take to test solutions. Take it away, Slingshot Catbot. A few episodes ago, Catbot helped us play a game in which our problem was to try to knock down a big pile of fluffy marshmallows. We decided that we could change one of two variables to accomplish this goal, either how hard we pulled on the slingshot or the angle of the slingshot. So we started by making our best guess at both variables and missed the marshmallows completely. The angle and how hard we pulled on the slingshot were the variables that made up our first trial. When we missed the pile of marshmallows, we needed a new plan. So we decided to change the angle of the slingshot, and we also made sure we didn't change how hard we pulled on the slingshot. We said that we should only change one variable at a time, otherwise we wouldn't be able to tell why our solution worked or didn't work. Although we didn't know it then, this is called isolating a variable. We're choosing one variable and giving it a chance to be in the spotlight. We choose it and it alone to change between trials. So we chose a new angle and started the next trial. And this trial was successful. Down went the pile of fluffy marshmallows. Officially, we can now say that we met the criteria of a successful test. Criteria are rules that are used to judge something. In this case, our criteria for success were that we A, knocked over every single marshmallow, and B, did it all in one shot. Let's see if we can name those things in another game. I mean, an investigation. Catbot, you get to be the cheering section on this one. Little Sabrina, you're up. In this game, we're going bowling. We'll say that the criteria for success are A, knocking down the pins, and B, doing it all in one turn. That is, getting a strike. Now, what are some of the variables we could change? Well, we can change how hard we throw the ball, and the angle that we throw it, and the mass of the ball itself, just to name a few. So the next step is to isolate one variable to change between trials. So, how do we go about doing that? Let's say we choose the angle at which we throw the ball. To isolate this variable, we have to make sure that all of the other possible variables stay the exact same. How can we make sure that the mass of the ball is the same? That one's easy. We'll just use the same ball every time. Bam, done. How about making sure that we keep the speed of the ball the same? Well, that's harder. I could just do my best to throw it down the lane the exact same way every time. Catbot, you measure the speed, okay? My first throw was about 24 kilometers per hour. Not too shabby. Let me try again. My second throw was only at about 22 kilometers per hour. Maybe third time's the charm. Yikes, that one was 21 kilometers per hour, and my arm's getting tired. Although my three values were close, they're not the same, and that means that another variable, the speed of the ball, would change during every trial. But we want our isolated variable to be the angle the ball rolls down the lane. So how else can we keep the speed the same? What if I had a few friends come along? If I had some help, my arm wouldn't get as tired. But then that would introduce some other variables. My friends are all really different, which is awesome, but not so good when it comes to trying to keep a variable constant. Because my friends are different heights and have different skills. It's not very likely that they'll roll the ball the exact same speed as I do. So that idea's out. I know, to help us out, we'll use a ball ramp. All I have to do is put the same ball on the ramp each time and let gravity do the work. Variable isolation accomplished. So engineers set criteria, or rules, when they're deciding if a solution to a problem is successful. And to really know if a solution meets these criteria, they have to isolate or choose only one variable. Next time we'll see how they change that variable, and only that variable, between trials to test the solution thoroughly. If the solution meets the criteria, it's possibly on the path to being a huge success. Hey there, future engineers! Who's ready for a little pin action at the lanes? Bowling. I'm talking about bowling. Anyway, it's finally time to test out the solution to our problem of how to get a strike at our neighborhood bowling alley. We know that engineers solve problems, and that part of the process engineers use to solve problems involves deciding on and then testing a solution. So what exactly are the steps that engineers take to see if a solution really works? First, you'll remember that we talked about variables, things we could change in order to, in this case, get a strike in bowling. And we also set the criteria that we could use to determine if we get a strike. In this case, those criteria are A, we have to knock down the pins, and B, we have to do it in just one turn. A challenge, maybe, but we totally got this. Now, we also said that as good engineers, we're going to choose one variable and isolate it, and set it apart from all the other variables to see if and how it changes things. And the variable we chose to isolate was the angle of the ball. In order to isolate this variable, we have to make sure that all of the other variables are constant. That is, they didn't change. That way, we'll know for sure what effect the changing of the angle of the ball has on the outcome, whether we get a strike or not. So we're keeping the mass of the ball consistent by using the same one every time, and we're going to keep the speed of the ball consistent by using a ball ramp. Now we're ready to perform a couple of trials to see if we can meet the criteria of our solution, all of which is a fancy way to say, let's bowl. For our first trial, we'll aim the ball ramp so that the ball will roll directly down the middle of the lane. When we let the ball go, we see that we knock some pins over, but not all. We might be able to get them with a second try, but that would mean that our solution didn't meet both criteria. Let's give it another go. This time we'll change the angle of the ball ramp so that it's pointed pretty far on the right side of the lane. Yikes! Gutter ball. We missed both criteria completely. Let's go with one more trial. This time we'll split the difference by setting the angle of the ramp so that the ball will hit the pins just slightly to the right of the center pin. That did it! We met both criteria. We hit the pins and knocked them all down with one ball. A strike! Yes! Not only is doing several trials helpful at the bowling alley, but it's also an important part of the process that engineers use when solving a problem. After engineers figure out the criteria that a solution has to meet to be successful, they isolate one variable to test. Then they change that variable between trials, and if the criteria are met, then the solution is a winner, just like we are at bowling.
Okay, so hopefully you enjoyed the next part of our video lessons. So it's great. I feel like these are some new videos. Actually, I didn't use these last year, but I feel like she's really good at explaining, and she uses examples to really make it simple and easy to understand just how it all works together. So hopefully you guys are understanding more about what a variable is, right? And how engineers use variables to be able to test out their possible solutions and then see which one works, right? So, so your review this week, this is your review sheet. There's 4 questions, so pretty short. So please make sure you just type in the correct answers, and then you can just email it back to me. And I feel like most of you guys have been doing it, so you're doing a great job, and it's easy to just get 100 because we go through the video, the answers in the video every week. So yeah, so just pretty easy assignment for over the break. If you are behind anything, just catch up. I just want you guys to come back with a clean slate so you can really feel good about yourself. And yeah, just enjoy your break. Okay, guys, we'll see you when we get back. All right, bye.